So today we are going to find out the efficiency of this gear pump. Okay, this setup is used to find out the performance characteristics of pump. In this experiment, we have different components. This is called as measuring tank. This is the gear pump. This is the prime mover, the motor, and these are the two gauges, and this is the wattmeter. This gauge is called as suction gauge, and it measures the suction pressure in the form of mm of kg. And this is called as pressure gauge, and the unit of this pressure is in kg per centimeter square. If you see these two pressure gauges, there the moment of this pressure gauge is in clockwise direction, and the moment of this pressure gauge is in anti-clockwise direction, because it measures the suction pressure. The suction pressure is always in negative. So we want to find out the efficiency of the pump. We need to take the following reading. This is called as suction gauge pressure, second discharge pressure, and the wattmeter reading. Now this is the pressure reducing valve. So we have to increase the pressure. We are going to take three readings on, that is 20 kg per centimeter square, 40 kg per centimeter square, and 60 kg per centimeter square. Now this is the measuring tank. The area of this measuring tank we are going to find out. The length is 0.36 meter and width is 0.26 meter. We are going to find out the cross-sectional area of this measuring tank, and we are going to note down the reading for rise of liquid for 20 centimeter. Okay, so I'll show you how you are going to take the reading, then we will do the calculations. So I have put the button on. Now I am going to put this button on. Now you can see that the pump has, this motor has started the pump, and the oil is, this is the reservoir tank. From the reservoir tank, the oil is coming to the pump. It is sucked into the pump. Okay, and this, you can see the oil is sucked, and this line, suction line, is connected to this suction gauge pressure. Now the oil is coming out through this port. This is called a discharge port, and that to the discharge port, to measuring the discharge pressure, we have connected the discharge gauge or delivery gauge pressure. Okay, now we will take the reading. So for taking the reading, you have to note down this reading. This reading is 300 mm of Hg. If you see 0 to 100, there are 5 divisions. So one division belongs to 20 mm of kg. This black dial, if you see, you can see mm of Hg reading. Okay, so minus this suction pressure is in minus. This suction gauge gives me reading in minus. So minus 300 mm of Hg. Okay, you can see this suction gauge reading. Now I am going to, this is the delivery pressure gauge. So I am going to open this relief valve. Now you can see the pressure of delivery has increased. Now I am going to do that pressure into 20 kg per centimeter square. Once I do this, you can see this is 20 kg per centimeter square. You have to read this black dial. Here also you have to read black dial. Now the watt reading is 410. Now we are going to move to the next. We have to measure the rise of level, and we have to find out the time. So we need a stopwatch for measuring for taking the reading. Okay. So what I have done, I have started this knob for taking the time required to rise of level. So this, if you can see that the rise of liquid or rise of level of liquid is, you can see, we will take it for 20 mm, 20 centimeter. Here it is in centimeter. So 30 at, we will consider this 30 as a 0, 30 plus 20, for 50 we will stop the stopwatch. We have started the time measurement by using stopwatch, and we will take the reading for rise of 20 centimeter. Okay, start. So we have noted the time for rise of this 20 centimeter. Okay. Then what we have to do? We have noted the reading. Okay. Suppose we have got. We'll stop this machine. Okay. Now, what we are going to do, we have noted this reading. Suppose we have got reading for, we have taken the reading for PD, that is 20 kg per centimeter square. We have got the reading minus 240 mm of Hg. And we had noted down the power reading, that is 710 watt. And rise of liquid is, time for 20 mm rise is 23.21. So we have constructed this observation table, okay, and we have taken the reading for this observation table. Then QA, that is called as actual discharge. How we are going to calculate the actual discharge? Area of measuring tank. As I told you that area of measuring tank, how you are going to calculate area of measuring tank? Area of measuring tank is, you can calculate length into width. So length is 0.36 and width is 0.26. Time required for rise of level is 25.2 seconds. And what is the level rise? That is 20 centimeters. So we have to convert 20 centimeter into meter. So we'll get this QA is in meter cube per second. This is the, we will calculate this and we'll get this answer. Now, the power generated by pump. So power generated by pump, we know that we had calculated PD, discharge reading, that was I think 20 kg per centimeter square, and suction reading we had noted down 700 and suction reading we had noted down minus 240. Okay, so keep this in mind. We have to find out what? Now we have to find out P, we have to convert this PD into, the PD is in kg per centimeter square. So we have to convert it into Newton per meter square. So what is the factor to convert the kg per centimeter square into Newton per meter square? That is 9.81 into 10 raised to 4. So we have converted P discharge, that is in kg per centimeter square, into Newton per meter square. And PS, that is suction pressure, that is in mm of Hg, we have to convert it into Newton per meter square. The factor is 133.3223. Once we convert it, PD and PS, that is in Newton per meter square, then we have to use this formula. HM is equal to PD divided by W plus PS divided by W plus the manometric height, the axis of the gear pump axis to the datum of this, or you can say datum of this pump to the pressure gauge. That distance is 870. So you can see that distance is 870. And now PS, we have calculated the value of PS and PD, but it is in Newton per meter square. And here HM is, the unit of HM is meter. So we have to convert this Newton per meter square, that is PS and PD, into meter. So for that we are going to use the multiplying factor, that is 9.81 into 1000. If we divide that to PS and PD, then Newton per meter square, we will get that Newton per meter square into meter. So we have done that calculation and we have converted that, we have divided that. Okay, so you can see that 3.924 multiplied by 10 raised to 6 minus 30.66. Why we have taken? We know we have converted this PD by multiplying 9.81 into 10 raised to 4, that is we will get 3.924. We have put it this value here, and again we have calculated PS here, and we have divided it by 9.81 into 10 raised to 3, that is we have to convert it into meter, that is Newton per meter square, we have to convert it into meter, and then we can add all the meters. So we added this and we will get 397.74 meter of water. So what is formula for P output? P output is, we know QA, we know HM, and specific weight of oil. Specific weight of oil is 9.81 into 880. It is given, specific weight of oil. So we have calculated P output, that is power output, and we know power input. So power output we have calculated. What we have got? 249.866 kilowatt. And you can see the power input 710 kilowatt. So we will divide power output divided by power input, then we will get the efficiency of the pump. So efficiency of pump is 35.57%. We have done the calculation for one reading. You can take the 2-3 reading more and you can calculate and you can find out the average efficiency. Thank you very much. Thank you very much.